In this lesson, I'll be discussing the process of texture baking. We'll start by baking normal maps, and in future lessons we'll discuss baking other types of textures. Baking computer graphics generally refers to taking some kind of calculated data and storing it somehow. Texture baking specifically tends to relate to calculating attributes on a surface, and then storing those attributes as a texture. For example, for a model that had colors in it, stored in the vertices as vertex colors, you could bake a texture and the computer would essentially paint an image for you, an image showing the colors of the verts for the object, but as a texture that would fit the UVs on the object. Another common type of texture baking is to bake the detail of a complex detailed model into a simpler model. Often this is known as baking bump maps or displacement maps, or more often as baking normal maps. Baking normal maps is probably the most commonly used baking method, so we'll start our lessons about baking by creating normal maps. So in this situation we have a rock created in the previous lessons. We'd also created an in-game model of the rock. So what we're going to do is bake normal maps that are meant to fit onto this object effectively by collecting the detail from the highest subdivision level of this object. And this isn't actually showing all the detail right now. So I could turn it up to a higher subdivision level. I can just push D on the keyboard in ZBrush, just D on its own to go up higher subdivision levels. And by going to the highest one here, what I'm actually going to do is export this as the high object so that I can use this as the target to get the detail from. So I'm going to use export now that I'm at my highest subdivision level here. So I'm just going to export this subtool. And I'm going to go to the baking folder here that I've made. And I'm just going to point out I'm using the C users public baking folder. The reason I'm using that is actually because it's a place that any user of the computer can get access to. It's relatively easy to make a baking folder or to have software make a baking folder on any computer because it's a pretty standard location. So if you have scripts or something and you want to have a bunch of scripted sort of automated systems that bake things for you, which is actually really common, probably something that hopefully I can do a lesson on later. It's really useful if you have that as somewhat of a sort of standard location that can exist, normally on most computers. It doesn't actually matter what folder you use to bake things. You can use anything you want. But in this in this situation, I'm just going to use this particular folder. And I do recommend using some kind of publicly accessible folder or something for it. Generally, all of the files that I create while I'm baking are just going to be temporary files. So I'm not really going to need to keep most of them because the real files that I actually want are going to be the Maya files and the ZBrush files and the resulting textures that I get. The sort of intermediate OBJ files and things like that, they're all garbage and I can delete those later. If you really want, you can keep them, but strictly speaking, it isn't necessary because they're extremely easy to re-export from ZBrush. And also, if you ever make any changes, it can be difficult if you still have all your OBJs around because sometimes you'll get confused and use an OBJ that doesn't represent the newest version of your file. So I usually get rid of all the old ones, and I have scripts and things that automate exporting the newer ones out. So in this situation, I'm just going to save over this high here. So I'll hit save, and this is in my C users public baking folder. So I'll save that off. Now I can hit save right now. I do want to point out one thing first though, is that in your export options, there's an option for merging UVs, and that slows it down quite a bit. And there's not actually any reason to have the merged UVs in the program that we're going to use for baking. So we're going to use a program called XNormal for baking. So the merged UVs won't really help XNormal for baking the high poly. So what I'll generally do is for faster saves, I will export that high without the merge UVs. And that way the OBJ file will save quite a bit faster because merging UVs can actually take a long time when you're saving the model. So if you want it to go a little bit faster, you can turn off merged. You can also potentially turn off that group box right there. In this situation, there aren't any groups that I need. There's a very good chance that if you did have a bunch of groups in your ZBrush file, that they wouldn't be of any use to you in XNormal, in which case it would make sense just to turn off a group as well. But I usually just turn off the merge button, and that's enough. And then I just remember to turn it back on after I've exported. So, if you're exporting from Maya or something, you do want merged UVs. So it generally is something that you want to turn on. I'm just turning it off right now because saving this file is faster. I mean, it's taking a long time to save this file even now, but it would be even longer if I had merged UVs turned on, because there would have to be like a whole step of doing that, which is actually quite lengthy. Okay, so I can turn it back on now if I wanted to. And then the other thing I can do, now that I have the high poly saved off, so that's the one that's going to have all the detail. So I have to choose what I'm going to bake to. So essentially the source of the detail, the source object, is this detailed, and the target, the thing I'm going to bake to, it's going to be this in-game model right here. So here's our in-game, and here's our detailed. So if I go back and forth, we can see the two of them there. And this is the object that we're going to bake all of our detail to. So very often the two meshes that you'll be baking with will be different from each other. You can bake information back onto exactly the same model, but for something like a normal map where what you're going to actually be representing is all the detail and all the small bumps, then it doesn't make sense to bake a normal map to its own object, except for the rare situation where you well, I didn't necessarily say rare, sometimes it's useful, but the situation will pop up where you actually want to bake to a lower subdivision level of the same object. That happens fairly often, but in this situation we just have a totally different object that we're going to bake to, and that'll provide a really good sort of robust example, so you can see that normally you can do that, and it works quite well. Most of the time what you want to have, though, is you want to have really good correspondence between the two objects. So in this situation, pretty much all these verts line up somewhere on the high poly object. So here's my detailed version of the object, which from now on I'm just going to call high. So here's high right here. And if I go to the low, or here's my in-game here, which from now on I'll just call low. So if I go to this low one, all these verts pretty much line up exactly somewhere on the high, and in this case I've actually projected them. Now they don't actually have to be exact, but in a lot of situations, if they are exact, it'll work out a lot better. If they're not exact, then you have to really think about how the projection is going to work and how the computer is going to figure out which parts on the low poly match up with which parts on the high poly. Because if they don't really actually match up in 3D space, that can be somewhat of a complicated process. We're going to use something called a cage that makes it easier, but it can still potentially get kind of difficult. So you generally will have the best results if your objects, if your low poly, in-game model lines up well with your high poly detailed model, which in this case they line up almost perfectly. I think in the last lesson I pointed out that I cheated in a couple places just by moving a couple verts here off the surface, but it was a really small amount, so it shouldn't really be a problem. So now I'm going to export the low out, and for this I'm using the in-game model. And when I do this, I want to have this merge on in this case. I do want the UVs to be merged. If two UVs are in exactly the same place, chances are those UVs should be merged. It's rare that you have edges that line up precisely in the UV editor that you wouldn't want to have sewn together. Most of the time, if the edges are in the same place, you want to sew them together. So, merging, just make sure that stuff that should be sewn together is merged together, and that's the default. So I just, I turned it off before, making sure it's on back again, or making sure it's on again now. So now I can export this. So here it is, and I can export over the low, although I'm gonna replace this in a minute anyway, but let's just go over there. Okay, so that's saved, and I can go to Maya. So now I can import it in, and in this situation it's in the baking folder. So that's in the public folder rather than the Joe folder, and it's baking. So I got this one. I could have also just exported a separate delete me file wherever, but I know that I'm generally going to use this one anyway, so this is fine. I'm going to save over it again in Maya, so at this point it basically is a temporary file, because you're going to see that when I save it out of ZBrush, it can potentially have different problems, such as all the normals being completely messed up here. And there are ways to sort of get that to work, because we can bake an object space texture. And that's something I'll talk a little bit more later, but most of the time what I recommend doing is bringing it in from ZBrush and then unlocking the normals, softening all the edges, and then exporting this one for the final baking process. So we're going to do two things. We're going to export this low poly. Let's double check that it has sensible UVs. Yeah, so there they are. We can also check that they're not all texture border edges. So for example, I can go to Display, Polygons, Texture Border Edges, and we see that there's just texture border edges around the seams here, sort of around the outline of these UV islands in the UV editor, and that's where we want them, right? If we saw texture border edges everywhere here, then I would know that the UVs on this were not merged properly, and that was something that I had to deal with. So I'm ready to export this out for XNormal. The one thing is, when you're going to export for baking, it's pretty important that the baking program sees the triangles exactly the way that your 3D software sees them. And sometimes different 3D software packages will triangulate quads differently. So this model is all quads and triangles, but the problem is it's not all triangles yet. And for baking purposes, you actually want to give it something that's all triangles, even if your model is normally going to be stored as quads. The fact is that at some point in the rendering pipeline or in your game pipeline or anything like that, at some point, every system's always eventually going to turn something to quads. So you want to make sure that whatever's baking matches however the quads would get turned into triangles. And in Maya, for example, if I want to see how it will turn into triangles, I can go in the attribute editor. Right, I can select the object here. I can go to the shape node. And in Mesh Component Display, I can see display triangles right here. So that's just Mesh Component Display, display triangles. And if I check that, we'll see a bunch of dotted lines, which shows how Maya would triangulate it if it was triangulated. And this is always the case. And these triangles exist. These triangles actually exist whether or not I show them. It's just the fact that right now, if I go and I edit this mesh, Maya might decide to triangulate this differently, and that's fine. But when the verts are in exactly these positions that they are right now, and the topology is exactly the way it is, this is the way that they will get cut up. So I have to make sure that my baking program, in this case XNormal, understands that exact way that they're cut up. So just temporarily, whenever I export, I'm going to make sure that I'm exporting a triangulated mesh. So if I'm going to export the low from this, then I'm just going to go to Mesh, Triangulate. I'm going to push F8 twice, and that's going to get me back to object mode, where the object shows green. And then I'm going to export this. So I can export this as an OBJ. And I'll export this into C drive, users, public, and then I'll grab the baking folder here, and I'll just make a shortcut for it so that I can get back to it again. There we are. And I'll save this over low right here. Yes. So now I have the low saved off. And now these are real triangles in the low. So I'm going to do something called creating a cage. And what the cage does is the cage basically acts as a starting place for searching. And what the computer does is it'll start from this larger object called a cage. And it will sort of start out here, and it'll search towards the original object, in this case just the low, the object that I have right now, which I could call low if I want to. It's not really important, but I could. And it'll search towards the low. And if it has to, it'll keep going past it. And in XNormal, or most baking software will do this, as it searches, wherever it hits the high poly object, whether it's in front of the low poly or whether it's right through the low poly, wherever it finds the high poly object, the source of the information that it's looking for, that'll get applied to the matching place on the low poly and on the cage object. So it's just a place to start searching from. And often if you start searching for detail, you want to start a little bit farther away from the object. You have to be careful not to start too far. Otherwise, you might catch things you don't want to catch, such as, let's say you're baking a character's hand. You don't want to catch the wrong fingers on different parts of it, which is a frequent problem actually when you're doing things like that. So you're careful to move the cage, but you're careful to move the cage so it doesn't like expand so much that the fingers go through each other or something like that. So I'm going to create the cage here, and I do this after it's triangulated. And I'm going to actually undo this when I'm done. And if I ever export a cage again, I'm going to triangulate and make the cage all over again, which is really easy to do. If you always make the cage right when you make the low, then you're guaranteed that they match. The cage has to match the topology of the low object precisely. So I'm going to go into Edit Mesh, and I'm going to use Transform Components here. So now I've got this node applied, and in the local translate, I can punch in a small number here for just how much it should move. So let's try 0.5. Not bad. It's probably enough. As long as the high poly object never sticks up farther than this, it's going to be okay. I could also try like 2 or 3. 1, 2, 3. Any of those are probably fine. In this case, just to be extra safe, I'll use 2. I could probably get away with less than that. It really just depends how much this object deviates from the high poly, and the more extreme the differences are, the larger a number that I'm going to have to start with here. And that's going to push my starting place out a bit. Of course, pushing it out too far, right, in a lot of cases with a lot of models can potentially cause problems. I think with this rock I could push it out really far and it wouldn't cause any problems because it's just a rock. But with things like hands or legs on characters, trees, things like that, it can start getting a lot more complicated when you have different branches of the geometry coming out. So you want to try to find the smallest number that will work. The smallest number that totally hides your high poly object inside of here, or that would if you had a high poly. So this should be okay. So now I export this as the cage. So now I've got the cage exported to the same folder. And now I'm just going to undo. So I'm going to undo back to before the transform and before the triangulate. I don't need that triangulate there. It's just there for X normal. It's just there for whatever the baking software is going to use. I can rename this low again if I want. It doesn't really matter that much. Now this is actually the Maya file that I would save here. So this is ultimately my in-game version of this file, and I could come up with good names and everything, and put together sort of a final scene here. In this case, all that I've actually done is repeatable actions that I would always do whenever I bring something in from ZBrush. So there's nothing sort of special about this Maya file at the moment. There's nothing I really need to keep, because every time I bring something into from ZBrush, it's pretty normal. I pretty much always use unlock normals, soften edges. So there's not a lot of I haven't really done anything special or worth saving in Maya at this point. So in a lot of cases, if you have your in-game version and your high poly in ZBrush, that'll be enough. Sometimes though, there is special custom data that you've got somehow in Maya. If you have spent some time setting anything up just right in Maya, then you do have to be careful to make sure you save that Maya file. But I try to work in ways most of the time where I don't have to maintain a separate Maya file if I don't need to. And in a situation like this, I know that everything that I need actually is in that ZBrush file somewhere. So now that I've actually exported out the low and the cage from Maya, and I've exported out the high directly from ZBrush, now I can bring those all into XNormal and get ready to bake the texture. So here's XNormal. This is a free program. By free, I mean free as in beer, as in no cost. You can download it without paying anything, legally. It's a free program that you can install, and it's a real sort of staple in the video game and VFX industries. It's tremendously useful. It handles extraordinarily high polygon counts on things that are way higher than most software is going to deal with properly. Like, you can get meshes into this thing that will never properly import into Maya, where Maya is just way too slow to deal with it. And that's one of the reasons it's so useful for baking. And that's one of the reasons that this program is so useful, is because it can bring incredibly highly detailed objects, the sort of poly counts that you could only normally have in ZBrush. You can bring those objects in here and actually bake to them. Part of it because you don't really have to see those high poly objects in here. You just load in, you just load the file, and you don't actually do anything with it in here aside from specify some attributes. So really useful. We're going to use this for normal map baking, although we can bake a lot of other kinds. Hopefully we can do that in further lessons. But we'll start just with normal map baking here. So the first thing is we'll reset all the settings. So we've got like a blank slate. So go down to settings and examples. I'll hit restore default settings. Say OK. And now it should be the same as what yours is like if you just start from scratch, which is really useful. You can save settings using the same section here in the settings and examples. So once you've got sort of settings that you like, you can save them off. And I've got a lot of files that I've saved off already. But now we're ready to start opening up our files and setting this bake up. So here's our high definition meshes. So we can go in here, and the way it works is we can click on one of these slots. You'll see they highlight blue when they're selected. If I right click, I can say add meshes. And then I'm going to go down here and I'm going to find my baking folder. So here's the hi.obj. There we are. Note this ignore per vertex color checkbox right here. At the moment, we don't need our vertex colors, so we're not using that. But if we had polypaint or something in ZBrush and we wanted to keep it, we wanted XNormal to actually be aware of that stuff, we'd have to turn this checkbox off. Right now it doesn't matter, but there are times when it would be useful. And then we have our low definition meshes, so I can go into our low definition meshes, and here's where I can load up our low. So I can right click and I can say add meshes. So here's where I pick the low. Now for the cage, we're not going to add it in the same way. For the cage, I have to be very careful and make sure that I left click, just regular mouse click, once on the low, and then I right click and I say browse external cage file. Then I just choose the OBJ file that matches. So here's the cage, and I exported this one, and I know it's exactly the same shape as the low, just inflated a little bit. It's got the same topology, didn't make any other edits, I just inflated it a little bit. So there we go. Choose that, and it's going to warn me. It's going to say, you know, they have to be exactly the same topology. And they are. We know they are. So, okay. That'll be just fine. Use cage is checked, so that's good. It's going to use a cage. The frontal ray distance, the maximum rear ray distance. With a cage, it's not as important, but you can try just making these around the same numbers that you used for the cage. A little higher or lower sometimes is fine. But that's a good starting place in this situation. I don't think that these numbers will be a big issue in this situation, but sometimes they can be more important. What I'll usually do is I'll try to measure it. If you want to, another thing you can do is you can double whatever your distance was, in case you're worried that you might have to sort of look a ways through. If you're worried that your high poly object is kind of deep inside of your low poly object, then you know, you might be able to make these bigger. I'm not actually sure how much it matters with regards to the cage. I usually, when I'm actually baking with a cage, I rarely have to mess with these numbers very much, you know, if ever. I usually only have to deal much with these numbers when I'm not using a cage. So if you're using a cage, these numbers are mostly a non-issue. But I would suggest starting at about the same number that you used in Maya when you inflated the cage. And I think I used about 2. And then, you know, optionally you could double that number if you wanted to. Possibly cut it in half if situations weren't working well. That's usually what I do is I just double this number or I cut it in half and I see if it's, you know, doing different things. Because this is just how far it'll search from the cage or from the low to find the high poly stuff. Again, when I'm using a cage, I normally don't really have to worry about this too much. So that's why I just punched in double the number that I typed in Maya. I don't think it'll matter very much. So let's go into our baking options at this point. And this is where we get to decide what to bake. Now, I just set this up to use our same baking folder. And I'm going to set this to TIFF. And I'm going to bake this to low. .tiff. Now, the reason that I do this is because TIFF files are actually significantly more accurate than a lot of the other files available here. Most of the files are going to be 8 bits per channel. TIFFs are going to be able to store 16 bits per channel. PNGs can store 16 bits per channel too, but I think when XNormal saves them, it only saves them as 8-bit per channel. So if we want sort of the higher color quality, which is particularly important for the way that I'm going to bake the normal map here, If we want that higher color quality, then I'm going to have to use TIFF. There's another method of having even higher color quality called EXR. And EXR files can be really high quality. I don't actually need something that's that big and heavy for the moment for baking normal maps, but there are some situations where it's useful, such as with ambient occlusion textures and things like that. But in this situation, I'll just use a TIFF file, and that is good enough. In fact, that's exactly the file you want. I would strongly recommend for doing normal map baking that you use TIFF files if you're using XNormal, and that, you know, if ultimately you need another kind of file, that's fine. You can just open the file and save it off as another kind later. In fact, we're even going to use a tool in XNormal that does that. But here's my normal map options over here, and you see by default XNormal just bakes a normal map because it's the most common kind here. You know, above it we have some really common options, just like the size. We're going to bake our texture 512 to 512. That's fine. You know, sometimes I'll go up here. Normal map options, or normal maps tend to bake so fast that it's not really a big deal. Like I can bake like a 1K map right off the bat. With a lot of kinds of maps, what I will do though is I'll bake a lower type first, or lower resolution first. Make sure it's working. You know, sometimes even smaller than that. Sometimes like 256. You know, if it's AO and I just want to see if it's working, then if I bake a 256 map right away, I'll get a basic idea of whether or not my ambient occlusion settings are working. You know, whether or not my normal map settings are working, whatever settings it is that I'm trying to get right. By using a low texture size here, I'm able to do some tests. They render very quickly because they're at a low texture size, and then after that I crank it up. When I'm doing final renders, I usually render to 4K, sometimes even 8K, depending on exactly you know, how much resolution I need. But even if I only need like a 512 texture, the thing is that normal maps tend to render so fast that I don't mind having a bit too much, because I can always downsize that later. And I'm sort of a big advocate of working too high at first and then downresing things later on. Sometimes during the process, you know, having things higher than you need them while you're working helps a lot. And then if you ever do need to sort of up the quality of everything later on in the process, you can go back to your higher res things and you'll find that a lot of that's already done for you. So I generally will create things higher quality than I need them to be at higher resolutions than I'm going to ultimately need, and then sort of downsize for whatever my final use is. And as long as you're like not running low on system resources, then you'll be able to do that. So in my normal map settings right here, it's set right now to bake a tangent space map. I'm going to bake a regular object space or world space map. So I can turn this off right now. Now, the reason I'm going to do this is because tangent space maps are generally better, and they generally are what you ultimately want to use in pretty much any program. Thing is that tangent space maps, they are very particular about exactly how they work. They use very precise math. That math is different, unfortunately, in most game engines and most 3D software packages. And there's a lot of things with the tangent space map that can go wrong. They're very dependent on the exact normals and tangents on the mesh, for example. There's a lot of things that can go wrong on a tangent space map. So what I like to do, and what I will very often encourage people to do, is to bake in object space first. You create useful object space mapping, which we'll see in a minute. And it's really easy to convert those object space maps into really good tangent space maps afterwards. And by doing it in 2 stages, we actually separate out part of the process so that if there are any difficulties in making that map, we'll know sort of exactly where those problems are coming from. You know, we'll know if it's a game engine issue, mismatch, or if it's a geometry error, or if it's a projection error where the cage doesn't line up. You know, doing it in those different stages will really help us to verify exactly where it's working and where it isn't working. If you're baking things and and it's going very well for you and you know that it's safe and your process is fine, it's perfectly okay to bake straight to tangent space. It can be more difficult for troubleshooting though. So as soon as I'm in a situation where I have to do any troubleshooting, or as soon as I need to be careful about something, I will not bake in tangent space, and I'll use a sort of longer, more fully correct method. And by doing it in object space first and then converting it into the tangent space map afterwards, I can sort of be sure that I'm doing everything right. Keep in mind also that when tangent space is turned on, right, this tangent space that it's talking about there is only compatible with certain engines. So, it might work in some renderers but not others. It might work in some 3D apps but not others. It might work in some game engines but not other game engines. you have to know exactly what your tangent basis is, exactly how the math is done, how the shaders work in that program, and you have to do exactly the same thing, in any other software that you're using. So unless you really have that whole pipeline very, very perfectly figured out, you're better off using something that has some kind of conversion process at the end. Where right at the end, once you've got everything working perfectly, you can go, okay, now I need to target a particular game engine, and then convert to get a proper tangent map for that exact game engine. If you bake right to tangent space, you're just going to get xnormal's default tangent space, unless you've gotten a plugin for xnormal for something else. So that's why I'm going to turn this off for now. But if you really know what you're doing, and you can turn it on, but be careful if you turn it on, because you have to know that your pipeline works precisely if you're going to use tangent space immediately. So I'll turn it off. I'm going to hit close. So that's set up. And if I want to do an initial bake, let's do 1K, just 1024 for the texture size. So I'm just baking the normal map. So now I'm going to go in and I'm going to hit generate maps. And the computer will start thinking. So it says notify tile updates here, which means it's going to start showing me a preview right away. You can see it takes a while just to read. I mean, it's reading that high. Well, that high is 4 million polys, or 4 million verts, I should say. So it's probably about 8 million triangles. So that's pretty high. So we'll just give it some time there, and then it's going to kind of sort it out, and it's going to figure out how to get the ray tracing to run as fast as it can. So generating nodes, etc. There's always a bit of a warm up right at the beginning, where it just set everything up. So now it's warning me. It says, "Do I want to overwrite the file?" And this is just because I've already baked another file before that was low normal TIFF, and I just have it set to just automatically bake over this. And the way that I normally work is that as soon as I have a file that I like, I rename this or copy it, put it somewhere else. So I always know that this low normals file is like temporary garbage. It's always something I can overwrite, because if I ever get something that I think is important, I will copy it or save it into a more appropriate place. Remember, right now it's just C drive, users, public, baking. That's a terrible final location for any files. That is just a temporary location that I'm using for all this baking intermediate work here. So I'm going to go OK, start baking over that, and here we can have our object space texture. Looks pretty much exactly the way I want it to look. What we really notice about this is that because it's a full 3D object, and it's got all sides. It's not like we deleted all the polygons on the bottom of the rock or something, because it's got all the different sides on it. Pretty much all the colors of the rainbow are showing up in this somewhere, and that's one of the sort of main differences, is that you'll see these sort of large scale sort of rainbow gradients all over the object when you're in an object space map. And later on, when we make a texture space map, it'll mostly all just be much closer to this background color here. That's the really big difference between them. So I'm going to hit close. So now we can actually try this map in Maya. So I'm going to go in Maya. So in order to test this, what I'm going to do is I'm going to duplicate the object. So here it is, and I'll move it over to the side. I'm going to call this test OS for object space. I'll make a test TS for tangent space afterwards. Ignore that box that popped up for a second because I hit a stray key there on the keyboard. Yeah, normally I should just be able to go in here and say test. Rename it. That should work just fine. And now what I'll do is I'll just assign a new material. I don't really have to assign anything all that special for this material. I can say assign new material, and I can just get a standard blend. Even though I wouldn't normally use a blend for most things in real life, I'd use a better material than that. Just for a test, it's going to work just fine, because all we really need to see is whether or not our map is working well in this object. So now that I've assigned that, I can go to the bump mapping here, and I can click in this slot to add a new map. So a normal map in Maya goes in the same place bump mapping goes. So I'll click in here, and I'm going to get a file, so an image file that I use. So I click File here, and then we get the Bump 2D node, which is ultimately connected to the file node that we'll use. And the Bump 2D node here it tells us what kind of file that we're using. You know, whether it's a bump map or a tangent space normal map or an object space normal map. In our situation, we made an object space normal map. So let's go down to object space normals. So now we know that's the kind we're going to load up. And then I'm going to click and bump value, which will take us to the file texture, ultimately. And here's where we finally get to load our texture. So click in here. Choose our baking folder. Here's our low normals. That's the one we just made. Open it. So now I've got our map opened up. If I orbit around in the viewport, in order to see this, I can push 6 on the keyboard, which is going to show textures. There we go. There's the normal map. So that is the normal map that the computer baked, which has, you know, as much of our detail as possible from the high poly object. Now there are, of course, some UV seams on my model. So wherever those seams are, we're potentially going to have some minor seams in here too. But really, you know, for the most part, this looks pretty seamless. You know, if there's seams in there, they're not super obvious. If I click on this, I can actually see that there's a seam running right down there, up here. But if I turn off, you know, that isn't terribly obvious. I think I have to zoom way in to really see that really faint seam. So it's right there, but I mean, I have to really zoom in to see that. That's a 1K texture. I could create a smaller texture here. You know, in an actual game, depending on how important the object, you know, would be, like chances are in a lot of situations it'd be a lot smaller. Well, I could paint a much smaller one here. Generate, just overwrite it. So I could just bake it again and just use a really small size. In this situation, it's not even it's not even worth it, because it takes so long just to bake the map anyway, just to get started baking the map, that turning the size down doesn't make it any faster. You know, in which case you may as well just bake the normal map high and then downsize it afterwards. You could downsize it in Photoshop or something else after the fact. You know, I'm gonna, as I said before, I'm gonna convert it anyway. So I just wanted to sort of quickly get an idea, or quickly show you an idea of what it would look like. Here, so there's an example of it at a lower resolution. Right, so now you can go in and we can see this. It looks like it's already auto-loaded it. So I can go in and here's our map and I can reload, but I'm pretty sure it's already done that. Sometimes mine's clever about auto-loading stuff. You know, so if this object's not all that terribly important, if we're further away from it, or if we just have, you know, fairly low system requirements where we're not, you know, able to use a higher texture, well, then, you know, even this doesn't work too bad. Basically, it breaks down when you get really close up to the object. It stops being all that descriptive, but, you know, that's a 256 texture, so not too bad. Now, ultimately, what we want to do is we want to convert it. So here's where chances are I would just go find a really high one, bake that out. So here's a 4K map. That's, of course, in a lot of situations, way more detail than you need. But in some situations, it's a good amount. And it's, of course, also relatively easy to, you know, to downsize it or whatnot. And what we're going to do is we're going to create a tangent space map. To make the actual tangent space material and to check it out, I'm just going to do sort of the same thing in Maya. I haven't actually made the map yet, but since we're just waiting for X normal, I can do this anyway. So I can just duplicate the original object again. And for this new object I've got, I can call it test TS. Okay, so the other material that I made, the first one, that blend, I could call that other one test OS mat. And now I can put a new blend on this new object for the test TS object. And for this new one, I can call it test TS mat. And I'll be able to load it in here. So just like with the other one, I can click to bump mapping, and I'll be able to add in there. But I don't even have anything to connect to it yet, because we got to bake something out. So let's just go back to X normal, which should be done baking now. Oh, still thinking a little bit, because I have to confirm that it's okay to overwrite. So here we are. So we have this object space mapped, baked, and it's baked at a pretty high resolution. So what we can do now is we can make the tangent space map, which is what's going to be needed most of the time. Now, the way that I'm going to make this tangent space map is going to be a MIKK tangent basis map. And as I was saying before, there's a lot of different tangent basis that can be used for different software. Every different game engine, different app, it's going to have sort of its own way of working. I wish they were all standardized. It seems like they're all standardizing more towards MIKK. They're all sort of getting more similar, and more things are starting to standardize on it. But there's still a situation where there's still a lot of different things floating around in the industry, and it's not all the same right now, and you can't really depend on things being in the sort of the right tangent basis. If we were to consider the MIKK tangent basis to be the right one, we can't depend on all programs doing that. In this situation, Maya is the new version of Maya as of now when I'm using this. Maya 2015 is the one I'm using in this example. Maya 2015 is reasonably close to being an MIKK map. It's not exact, but it's pretty close. At least I'm pretty sure it's not exact. I think I've noticed a few minor problems, but it is awfully close. So if I want to use it, we should get reasonably good results if we use the MIKK tangent space or tangent basis. And they have a tool in XNormal that does that. And I can go into Tools, and then I can go into Object Tangent Space Converter. So we have our low poly mesh, and we have a normal map, and then we can output a normal map. So in this case, I can use a low OBJ right here. I can also potentially use an FBX file, and if you want sort of to get the most accuracy, you probably are best off using an FBX file because it might contain data that's just a little bit better, possibly a little bit different than this OBJ, and chances are the FBX file is the precise file that you are bringing into your game engine, whereas it's unlikely that I'm bringing an OBJ file into the engine. So I can redo this at any point using an FBX file instead, but for now, just for using this in Maya, it'll work just fine if I use an OBJ file. And now for my input normal map, I can go in here and I can choose the normal map that I just made. So here's my 4K map. It's a huge texture. That's fine. Open it up. Now I've got my output normal map. So this is basically the same. I'm going to save this as a target. I'm just going to call this low normals mikk.tga. So it's pretty much the same name as my other one, except it's got mikk on the end, and it's a .tga for a target file instead of .tiff for a tiff file. So now it says here, convert object space to tangent space. So what it's going to do is by using this model, it's going to take this object space normal map that we made before, and it's going to convert it. It's going to give us a new map that is a tangent space, a normal map, using the MIKK tangent basis. And when I hit generate, it'll actually create that, and it tends to create this pretty fast. So let's hit generate. So it's just going to go through here. It's going to think about that map. I mean, it's already done. It's dilating the map now. It's arguably dilating and saving took longer than actually recomputing it there. So it's pretty fast. It can be sometimes a bit longer if you have more complicated objects, but this really isn't too bad. Generally, this step should be, close to instantaneous. So we've got our preview right there. So this is what a tangent space map typically looks like. It's a lot more based just on that sort of standard, little bit desaturated blue color there. And then we can see some sections where there's some red and there's some green and there's some darker sections in there. But it's less of like a giant rainbow everywhere, whereas the object space, had really wide scale variations. In this one, the variations are they're on a smaller scale. They're sort of local to the part of the surface that it's describing. And this is the way a tangent space normal map usually looks. So in Maya, if I want to test this, I've got my tangent space map, so I can go here and I can right click and go to material attributes. And here's the bump mapping. So remember, I already made a new material for this, a new blend, and I can load in the bump map. So click in the bump map slot, click on File to load the new file I made. I'm going to click on, actually I've got it my use as, so it's set to use as bump right now. So remember, before I chose object space normals here, because the other map that I made before, the really rainbow colored looking one, that was the object space map. This is the tangent space map. So this time I choose tangent space normals. Then I go follow the bump value here, which is where the actual file is and where I get to pick the actual file to use. So I click in that slot. I'm in the file node, and here it says image name. So now I get to load that tangent space map that I made. So there's low normals TIFF, that's the old one, and here's low normals mikk.tga, that's the new one we just made in tangent space. So I'll click on it, hit open. Take a look at that map, and looks just fine. So typically, most software, most renderers, most game engines, most everything is ultimately going to want this tangent space map. But there's a lot of times when you're creating the map, you can run into various problems. Making the object space map first and then converting to tangent space gives you a lot more flexibility. You can cheat, you can paint on this object space map. You can move verts around on this model slightly to kind of cheat in the UV space or in the 3D space before you bake onto it. There's lots of interesting things you can do when you do it in sort of 2 steps like this. It allows for a lot more cheating, and it also allows for a lot easier troubleshooting. And as you can see, that step of converting it from the object space map to the tangent space map, that step is super fast. And of course, the most important reason why I might do this is because if I want to go into multiple game engines or multiple rendering applications or something, and they all have different tangent spaces, I only actually have to bake it to the high poly model once when I make the object space map. After that, I don't need to do anything more with the object space, or sorry, with the high poly model, I should say. So the object space is done, the high poly model after that point, none of the steps after that point require the high poly model. So all the steps after that are going to be really, really fast. The high poly model, that step is the slowest when I am sort of baking it, just because of how big and complicated that file is, right? It's 4 million verts or something. It's incredibly big and complicated. I mean, you might have a model that's 40 million or hell 100 million verts. I've seen it happen before. And as we go into the future, things are just going to get more complicated. So only having to deal with that once, and then being able to go in and target different meshes and fix it up for different game engines and such. After the fact, it really helps that way, being able to do it in the 2 steps there. So that's why I'm a big advocate of the object space to tangent space method. If you don't need that stuff, and that you're not having any problems, then of course you can bake directly to tangent space. And if you do want to bake directly to tangent space, then we would just go in here, and I'll actually just do this. So if we go to our baking options, I'll call this low normals direct mikk, just to make it really obvious. So here's one where I'm baking to that right away. Then I can turn on tangent space, generate. All right, and again, this is the slowest part of the whole process right here, reading this hi.obj. So if I already have the object space map, I can convert that map way easier than I can bake this tangent space map again. Just because it's got to spend time opening up the high object, and this object's not even that high. But once this finishes, it'll look pretty much exactly the same as the one we converted. So yeah, it's still generating. Finally, it's getting around to rendering it. So as I said, this that's the slowest part of the whole project right there, the whole process right there. Okay. So that's not too bad. So if I want to test the direct one, let's just duplicate this over here. This is test tangent space direct. So just assign a new material, grab a blend. Here's my bump mapping. So I just load a file. Use as, I'm going to use that as a tangent space normals. Click in the slot here to get the file itself. Open up the name. And now I should have a direct MIKK map right there. Open that up. You can see it has the word normals in it, and that's because I typed it in the name as well, and xnormal also adds it automatically each time it does a bake. So usually I just write, for the file name in xnormal, I just write low, because xnormal will add the additional information about it. But in this case, when I was showing it, I wanted to be very specific so that anyone watching this would understand that this is the normals direct as MIKK tangent space. So this file is sort of overnamed just to make it really clear. But now if I look back in here, there's my direct one. I could call this test, TS, direct, map. And these should all pretty much look identical. Now, of course, there is a big advantage in the tangent space map. It's important to make that tangent space map normally. You can't just make the object space map and then sort of leave it, because this thing will give you all kinds of problems. If you ever go in here and you do something like rotate the verts on this object, you're going to see all the lighting moves with it. Now let's see what happens there if I actually have a light in the scene. So if I go in here and I grab a light, so I've actually got a light. I can push 7 if I want to show the actual lighting. Right, so now I can see when I move this light around, I can see what's happening. Well, if I go in here and I select all the verts, so I'm just in vertex mode here. So if I select all the verts and I rotate them, the lighting follows them. Even worse, when I go in and I actually grab this light and I move it, the lighting on that model will just start doing senseless things. So the lighting stops doing anything that makes any sense on that model, because that object only works. The object space normal map only works when those verts are in that exact position according to that object. If those verts start getting moved around and start getting changed differently, things can break. So it's possible, like I could go in here and I could move these verts so this won't change it, but there's just so many things you can do to the model that will break it. Even just grabbing some verts and moving them and not moving others. So there's a lot of situations that can give you some pretty strange results. Whereas over here, because this one here is in tangent space, if I go in here and I start rotating it, the lighting keeps working correctly, right? I'm not rotating the lighting as well, because the light stays over here and I can rotate the verts through it. So what that means also that if you're using tangent space maps for this normal information, then you're going to be able to have characters that are rigged, and you can have bones in them, you can have the characters moving around, you can have the geometry deforming, and you can still expect the normal maps to work. Whereas with this object space map, it can't deform. You couldn't realistically put that on a character and expect it to make any sense in your game. So it's so important to convert things into those tangent space maps so you can actually do them. But I still really, really like the object space maps as a in-between method, going from the high poly towards finally getting the tangent space map on the low poly. It's really nice to have that in-between step of the object space map on the low poly, just to make sure that everything's working up to that point. In this example, everything has gone smoothly, but there's a lot of situations where things will not go so smoothly when you're baking normal maps. So in a lot of situations, it can start to get pretty frustrating. So because of that, it's often nice to have those extra steps in there. But I think that's about it for this lesson. So in future lessons, I'll discuss baking other kinds of maps and why we might want to use those.